Okay, welcome. Don't everyone rush the front. This is my talk on Apache Pulsar development using Java. If you want to use another language, you can too, but today obviously we're doing Java. So I've been doing streaming, big data, IoT, Java, a whole bunch of stuff, and a bunch of different companies. Now I'm at Stream Native, where we do Pulsar. I'm also involved in some other streaming communities, Flink, NiFi, Spark, Delta Lake, a bunch of other things. And I've got stickers for that. I call that the flip stack, Flink, Pulsar. Sometimes I add some other letters onto that. Weekly newsletter covers that. Links to free articles, code, videos, and any tools I find that are cool, good demos, anything cool for that week. One thing is different about Pulsar versus if you've seen or used Kafka. It does something a little different. It doesn't just do streaming, which is pretty cool. We also support a bunch of different protocols, and I'll show you, I could just use other people's libraries. So say you want to add Pulsar to your environment, but you don't want to rewrite any of your apps, or maybe you'll rewrite apps later based on, maybe you do a blue-green test, or you'll load two different things at once. So we have native support for a couple different protocols. So you could just pick up your Kafka app and point it to our cluster and just have it work. So let's get into it. I put some cool pictures here. So it is unified messaging. What this means is if you have JMS now, if you have Kafka now, if you've got Amazon SQS, if you've got some legacy MQ, if you've got MQTT, we could do all of them. We support all those protocols. We support all those messaging paradigms. So if you want to push data in like you did it 20 years ago in JMS, you could do that. It's a good way to pick up some of those legacy apps without having to rewrite them and get that data sent right to your modern messaging systems. Like if you wanted to take data from a legacy app that did JMS and get it into a Spark app, Pulsar could do that for you, no change of code, and you instantly get scalability. You also get some of the built-in features of Apache Pulsar. And all these are, when I talk about features, these are all in the open source free version. You do not have to get support version. You don't have to run a special cloud one. There's no weird license. This is all Apache license stuff. So you just get this. You could just download this, run this in your environment. I know people running petabytes, thousands of nodes with a minimal staff, just kind of works. So underneath there, tiered storage built in. So you could just decide, hey, I'm just going to store every message that I've ever gotten. Obviously, that could get expensive if you're storing it in regular storage nodes. So you could tier that out to S3, to MinIO, to, Google Cloud, wherever you might want to have that tiered storage, HDFS, and then just use it as if it was in your regular messaging system. So what's nice is, say you bring on a new data center, you bring on a new app, and you go, I want to get the first message I ever sent and replay that whole stream in order. Some of it's stored in S3, some of it's in the current messaging queue. Doesn't matter. It'll retrieve it for you automatically. Obviously, grabbing stuff from S3 bucket's a little slower than grabbing it from a closer messaging node, but it's transparent. You don't have to rewrite your app. Don't have to do anything weird. Don't have to write an app that stitches together some backed up S3 data and current data and figure a way to join them. It just happens. You just say, give me the oldest record you have. And I could do that with Flink, Spark, with just a simple keyword if you want. Offset is maintained in the broker. You do not have to maintain it like Kafka. That is a good point. Instead of Kafka, where you have to maintain your own offsets in the client, I'll show you the architecture in Pulsar. The Pulsar broker doesn't do a lot. But one of the things it does is make sure it knows the subscription for everyone who subscribes to the data. So you could always go back. And what's nice is those could be shared. There's a whole bunch you could do there. That comes also under this multi-tenancy. So as opposed to systems where you get all your topics and it's in a big garbage bag list of everybody's topics, maybe you have security limits what you see, but it's all under one tenant. We have multi-tenancy, could scale. We have people who will run massive clusters, like say Tencent. Will probably, maybe they have 5,000 servers, maybe they have 25 million topics, but it's one cluster. With multi-tenancy, we set a tenant up at the top. This could be, there are a couple of smaller cloud vendors out there who use this to host other people, and they host it as Kafka, because we support the Kafka protocol. So you could get a cloud account of Kafka, and it's actually a tenant on a Pulsar cluster, and you would never know, which is kind of sneaky, but that's what, there's a couple cloud vendors doing that.
Is there a limit for scaling? Like, I know Kafka has some limits on the number of topics.
We do not like, that's why we have the multi-tenancy. We set up a tenant, and that could be a company, could be a group, an app, however you want to set it up. It's a virtual one, but it maps to security. Under there, you create namespaces. Under the namespaces is where we do our topics. Generally, we recommend 25,000 or less topics per namespace, but you can have as many namespaces as you want. With the newest version of Pulsar coming out in a couple of weeks, we up that to 1 million. We still have performance of more than 25,000 topics in a single namespace. Was a little slow because of the way you store on pointers and stuff, but again, 25,000, and then I have as many namespaces as I want. Millions of topics are pretty doable. There are some large companies like Flipkart doing that, though some people like to put a lot into less topics, but the multi-tenancy means you don't have to.
So in this case, like, can we use the Pulsar as a replacement of Kafka? Like, can we use it?
Yeah. Right now, you could download that today. There's a lot of people running the open source by themselves with 1-2 people who kind of know Pulsar. It just kind of runs. It was originated at Yahoo when they were building out their messaging platform, which they still use today. Yahoo got bought by Verizon, and Verizon spun them out again. They're still Yahoo. They're still running Pulsar because they can run all the messaging infrastructure from all the apps in one place at any size scale. We haven't had anyone hit a top limit. I mean, I'm sure there's going to be parts that slow down once you get into the hundreds of petabytes. We don't have any clusters bigger than like 20, 30 petabytes in RAM. Some people do in-memory data warehouses. That's pretty popular in China, combining Flink SQL against Pulsar. If you have to get back, billions of rows a second, you got to do some extra work.
Like, where does this run? Like, can we run it on OpenShift or Kubernetes?
You can run it in Kubernetes, and I'll show you why you might want to run it on Kubernetes. In the open source are the operators and the Helm charts. A little different from Kafka is the storage layer and the compute layer are separate. So if you're used to doing anything cloud native or Kubernetes native, that's pretty much your whole idea there, right? As opposed to Hadoop and some of the other things, yeah. So storage is in a different type of broker than your compute is. And that's kind of critical for doing, a Kubernetes deployment. But yeah, we have Kubernetes support, Docker, bare metal, all the major clouds. Plus, there are a couple of commercial cloud-hosted Pulsar offerings out there. Obviously, the company I work for does one too. Scalability, again, because we got the decoupling of those two guys, it's a little easier to scale things out. And what's nice there is because of the stateless nature of the brokers, you could spin them up and down extremely quickly. You don't have to worry about the storage there. And with the ability to time out messages or put them into tiered storage on a time basis, you could spin things up and spin them down very quickly without any loss of data based on your requirements. What also is nice is georeplication. Again, you could just have one massive cluster and you could have it span things. But as people know, once you start going across availability zones, against time zones, against or in between, there are people federating between different cloud and on-premise offerings within the same virtual cluster. Doing georeplication is an easy way to do that. You set up some configurations that says these namespaces or these tenants or these topics, they get replicated automatically somewhere else. And that's just not the topic, it's the security, it's all the offsets. You could have these things just automatically be distributed wherever they need to go without a lot of extra work. And that's in the open source one. You don't have to write extra code for that. And again, like we mentioned, messaging and storage. So things like RabbitMQ, we support that protocol natively. RocketMQ, which is a newer one in China, we support that protocol. And then there is a JMS protocol implementation from DataStax out there. That's not in Apache yet, but that is open source. And support for these other protocols, it's very easy for you to, replace SQS with your own Pulsar cluster in case like you were moving off of Amazon. If you use the Pulsar protocol, then you don't have to worry about where you're running it in case you have to move between clouds or run them all at the same time. And we do data streaming just like Kinesis and Kafka. It's pretty important. What's cool about the multiple protocol support, it's not a proxy, it's not an add-on, it's not a sidecar. It is a native part of the cluster. So the exact same support we have for the Pulsar protocol is the exact way we do Kafka. They plug in at the same core level. Pulsar is designed to be flexible because that's how it was originally designed. So anyone can add their own next layer of library support. So maybe you want to support CoAP, maybe you want to support some other open messaging protocol. Very easy to add that in there. And what's cool is I send a message in via Kafka. I do not have to pull it out via Kafka. Anything in, anything out. So I can have a Kafka producer being read by a Pulsar consumer, a Spark consumer, a Flink consumer, a Spring doing JMS, AMQP reader, MQTT, all simultaneously. And if someone decides later to change that message to Pulsar natively or MQTT, mix and match any way you want. What's cool is if you decide I want streaming, you don't change anything on that producer. I don't change the logical assignment of the topic or any of the DDL. All I do is if I want to read it in a streaming style, I just use a different type of subscription. That's I subscribe to this data within your code. So if I do a key shared style, this is the way you'd want to do CDC. If you want to do it Kafka style. With the key shared, I'll have the key maybe be the table name. So it could have one consumer of the data subscribe to one key, say one table. Keep that in order, keep it exactly once. Just like you'd want to do in Kafka. The other option is you could do exclusive, which is exactly the way Kafka works, where you get one and it just goes there and you map it up to a partition if you want. You can also set that up as a failover version, which is if that exclusive consumer is not available, we'll just fail over to a backup and they'll just take over from where they were. What's nice is since you don't manage those offsets in your code, you don't lose anything. There's no delay when I switch over to someone. We manage that in the broker for you. So that's a pretty cool way to do that. And then if you're doing traditional messaging, shared messaging works like a work queue. Anyone who has that subscription and it's shared, whoever gets the next message gets it, processes it, and then the next one's available. What's cool with subscriptions are I could have as many as I want, maybe probably keep it under 100 million to each topic, and it doesn't matter. Like if I can have a key shared, so I could have a streaming app pointing to the same topic as a messaging app. So I could have it process as a work queue, process it as a stream. That's pretty cool. What's nice with Pulsar is the data doesn't die until your subscription is resolved, unless you specifically set a timeout that says, I don't care, just kill the data. We have a lot of flexibility on how long you let messages live. And you have a lot of control over that, which is a nice feature if you don't want your data to be lost because of some unforeseen circumstance. But if you do have data that you need to push through even faster, and these numbers are significantly beyond Kafka, we could turn off durability, which is something you see in some of the JMS messaging systems. So if you don't care about it being stored, this is common if you have something like a log that keeps sending back 0. It's always 0, then once in a while you get a real message. I don't need every message. I just need them to get through really fast. You could turn that mode on. It's an option. We have partitioning if you want it. We don't need it for performance. We don't need it for subscriptions. Some people like to do it, and that can improve performance based on your use case. Again, if you're picking up a Kafka system, you might as well keep the same partitioning model. By default, we just have one partition for a topic, but that could support millions of concurrent messages. Doesn't matter. The way our data is stored isn't reliant on those partitions. That's just a virtual paradigm to make it more, make sense to people coming from the Kafka world. So this is what I meant, that separation of concerns. The Pulsar brokers do handling all those messages. So they do the routing, they do the compute, they do a little caching, they do the automatic load balancing. They handle that work for you, and that's who you talk to. Again, there's a proxy in there if you need to have a proxy in front of it, and all that kind of load balancers and everything. All the slides are already up. I'll make sure they're posted to the Twitter feed. Pulsar broker handles that part. The storage isn't there. This is how we could do this very easy in Kubernetes. Apache Bookkeeper is a data store that came out a number of years ago that works almost like a traditional database. So as opposed to just having a log file, this is a striped ledger system, makes it a lot quicker, a lot harder to lose data. It also means that because that storage is separated, when I'm getting data coming in, if I add a new node, it can instantly be added as a stripe of data. Because by default, we will stripe the data to 3 nodes. People coming from HDFS systems will remember that kind of idea. So that way, if you have a corruption somewhere, you lose a disk node, not losing your data. And it's very easy for us to recover. You add a new node, we add the new stripes, and we could instantly get that up to full performance of a system. Metadata is handled externally. This is where we keep, how many nodes are in a cluster, some of the metadata about topics, tenants, and namespaces. This is where doing these lookups could be an issue if you have more than 10, 15,000 topics in a namespace, because you got to do that mapping. This is an open API. This in the past was just Apache Bookkeeper, Zookeeper, which people will remember from Hadoop and old Kafka and a lot of other things. We've opened this up to other systems. If you're running it standalone, which, for development or for a small cluster, maybe 25,000 messages a second, something you might run on your laptop, you could just run a RocksDB, and that'll handle all the metadata. If you're in a Kubernetes environment, you're going to have etcd anyway. You could just use that as your metadata store. Makes a lot of sense in a Kubernetes environment, and that works out nicely. Yes?
Regarding the storage, what type of storage do you recommend for this?
As you might hear from Kubernetes people, from Kafka people, if we put SSDs there, or some other kind of fast drive, it's going to be faster. Does it need to have it? No. And again, because we don't have this for the broker nodes, traditionally we will have smaller clusters in Kafka because to add more storage, I could put a beefy bookkeeper node there to handle more storage. And if I want to add 100,000 more clients, I could just add some very thin Pulsar nodes that could have traditional disk or very little disk. They don't do a lot of disk storage.
It being a separate storage for the compute, does it not increase disk IO or a network IO time?
There is some, but most people have to do that anyway. Like even with Kafka, you don't have one node. So you got to communicate between the nodes. And there's always a lot of chatter. In recent benchmarks, the difference between Pulsar and Kafka is not significant for any use case. And for certain use cases, we're faster. For certain ways to configure things, we're faster. I mean, if you're at the point where you're splitting hairs, where you're worrying about microseconds places, you probably have some custom system you're using anyway. Yeah, there's no real concerns with slowdown around that. Multi-tiered architecture is pretty straightforward. Just to give you an idea, things that are built in, pretty traditional for Kafka and other messaging systems where you might have a load balancer handle it in. It's not a problem for Pulsar to understand where you came from. Pretty significant for us to route things around for you pretty easily. And we have a built-in proxy we could turn on, part of the open source, to handle, routing these things, depending on how advanced your infrastructure is. Again, people like Flipkart and Tencent because they're running massive clusters and they be coming from different systems around the world. You might need that. A lot of people don't. Depends on your infrastructure. We mentioned that multi-tenancy. Tenant namespace lets you break up the data a lot easier. Again, who wants to have a list of 1 million topics? Trying to list through all those is pretty painful. If you've done Kafka messaging or JMS, messages look like messages. You got some data, you got a key, got some properties, a couple different things in there. As the same as Kafka, all messages are raw bytes. And which means theoretically you could put anything in there. Do you want to do that? No. I mean, traditionally, people will put in JSON, Avro, Parquet, Protobuf, structured data. It doesn't have to be structured. It could be XML, it could be text, could be binary data. We have the built-in ability to split records. So if you want to decide you want to put in one giant file, we could break that up for you automatically, and it's transparent with the Pulsar client. You won't even notice it. Obviously, there'll be some time lag as you reassemble, multi-terabyte files, perhaps. We went through that subscription before. There's some common examples. This is kind of why you might want to do messaging. A lot of the traditional messaging use cases, you didn't keep the messages around. They were data's pretty small. That's kind of better for messaging. Again, having that so you have those shared so more people can handle that for you. If you need to roll back into your data, like we were mentioning, it could be stored in tiered storage automatically for S3. You could use the Java Reader API to decide where you want to go back to. And there's a couple built-in ones, the earliest, latest, things you'd expect to see. But again, this can hit any location where this data is. So you're not tied to you knowing what the first one is or if it's stored in a storage node. Different ways we have the messaging ordering guarantees. Depends on your use case and how you set up your data. If you send to a single topic or single partition, you're going to have a guarantee on order. If you send data to multiple partitions, it's going to be hard to guarantee you're going to get that data in order. Again, something you think about when you get the data. What's nice here is that's not based on performance, though. I can have one partition and still get massive performance. Again, depends on your subscription mode, lets you adjust how you're going to get these messages in order. One thing that's really critical with Pulsar is the support for lots of connectivity. So what it means is if you're like, well, maybe I want to try Pulsar, but obviously I already have Kafka, I've got MQTT, I keep those running, I could dual ingest using those same exact libraries, because I'll just turn on AMQP Rabbit support, turn on Kafka support, turn on MQTT support, and run all those protocols at the same time. So whenever those messages come in, just goes natively into Pulsar. We got full support for Flink, Spark, Trino. What's nice with Trino, can do instant SQL and Pulsar regardless of where the message is stored. So it just looks like a table to use. Same with Flink SQL, same with Spark SQL. Pretty easy to do. We support Kafka Connect, but we have our own set of connectors, which are easy to write. They're written in Java or JVM language. And there's all of them out there for what you expect to have out there. We support adding functions. These are not the same as Kafka streams, but you could run a Kafka stream server and point to Pulsar and run the same way. Ricardo showed that on our last conference. And you could write your functions in Java, Python, or Go. I think of the functions as kind of like database triggers. Event comes in into any number of topics, and I can apply a function that could do some different kinds of management of that data, routing, enrichment. Not as powerful as Spark or Flink, but good enough for doing things like adding a field, removing a field, doing a lookup. There's a built-in schema registry, and it'll manage it for you automatically. You have full REST and command line interface to be able to play around with these schemas, and you can visualize it in a lot of the different visualization tools. And this is, again, an open API. Use whatever schemas you want to use, but Avro, Protobuf, and JSON are the most traditional. And when you do a produce to it, I could just push a Java object to it, and it will just become a schema for you automatically. So you set up a Java bean. I do a produce the first time, it will build a schema from that. And then if I change it, it'll auto-version it for me. And then if I'm reading it from the other side, the Pulsar client will natively pull that out and map it to the right object for me, or I can access it in a generic method. And there is a translation layer if you got to translate a Confluent encoded object to a non-Confluent one. Those things get a little weird, but as you might expect. MQTT on Pulsar, this is the part where I was saying it doesn't matter the protocol. It's the same exact set of libraries. It's not a secondary system to do this. Same handler, same exact design. So if you want to add another protocol, it's not like something where someone's doing a kludgy way to hack it on. Same exact thing. Data comes in from whatever of these protocols you want to do, and you can pull it out any other way. And again, pull it out with Pulsar SQL, which is Trino, which will let you query even if it's tiered out. Just a diagram. That's my cat. Pulsar functions are, I mentioned that slightly, but if you run it on Kubernetes, which we give you all the operators to do that, you could consider this having your own AWS Lambda, your own little serverless event streaming framework that's triggered by events that come into Pulsar topics. And again, remember, it can come into that topic via Kafka, via MQTT, via REST, via WebSockets, or one of these Kafka Connect sources or a Pulsar source. However you want to trigger one of these functions to execute, and they'll run. This supports Java as well as some other languages. What's nice is it can be as many topics as input as you want, and you could change those dynamically through the APIs. So it could dynamically adjust, and you could assign what output topic when you assign these things. You could also have Pulsar dynamically assign topics. So say you have new data that you've never had before, Pulsar can look at some of the metadata and create a topic on the fly for you in these functions. So you could have something that does automatic ETL for you. And by default, we log errors or anything you want to use the logging for to a topic. So again, using our own dog food there. A lot of people use this to run machine learning, and there's a couple of startups who use Pulsar to run their machine learning. Pulsar functions for routing, enrichment, a lot of different things you could do with Java. If you want to run your own cluster, you could just do it pretty easily. Just download it if you want to do it bare metal style, and just type standalone, and it'll start running, and you can start using it. That's all you need to do. We've got the directions to do it with Kubernetes, with all the operators, or with Docker, or on any of the cloud vendors. The easiest way to create your metadata is through the command line. This can also be automated with all the DevOps tools you know, or through the REST interface. So I could create tenants, create my namespaces underneath them, create my topics. You'll see what's interesting with the topic name is persistent, because we could be non-persistent. Then it's tenant, then it's namespace, then it's topic. So you got to keep in mind, if you, by default, leave out persistent, public, and default, that's where it's going to put it. That's our defaults. So if you don't want it there, put a name in there. Consuming messages, really easy. When you're done, if you want to shut everything down, delete it in order. Delete the topic, namespace, tenant, boom, throw it away. You're good to go. Functions, I could just use standard Java functions. If I don't care that it's running on Pulsar, use the built-in Java function, give it a name, have an input come in, have a return. This can be deployed on Pulsar and will take in the input you supply from an event and have it output to another one. And if you don't care about any special features, that works pretty easy. If you want to use the SDK, you get some extra features here where we support different types, schemas. We give you access to a context. This context will give you the ability to access logs, access state, apply a consistent state that you can access from any runtime, and let you do some debugging and some other fun things. If you're going to use the clients, got support for things like built-in back pressure, sending things synchronously or asynchronously. What that means is if you want to send a message but you want to wait until Pulsar acknowledges it, it'll wait a few milliseconds until it gets that acknowledgement. As opposed to some other messaging systems, we can have an async per message. We could also give you some back pressure and say, hey, send as fast as you can, but once I hit a certain level, wait, block until I get the acknowledgement that all those messages were successfully written, which is important if you're worrying about data, something crashes. Very easy to set this data up. If you just use the out-of-the-box Pulsar Java library, but better than that, the Spring team and us have been working on a new Spring library to do this to make it easier. That will be announced at Spring 1 in December. Me and Sobi will be showing you the latest version, and it'll be on Start Spring IO, so you'll be able to just create a Pulsar app that easy. Pulsar template, put your bean in there, boom, set a schema if you want to, send a message, easy as that. Makes it pretty simple to do. Subscribe to data. The only difference between our library and Kafka is you can pick that subscription type. We'll default to one for you, but you really need to pick a subscription because they work differently. Routing things when they come through a function, really easy. As you see here, I could dynamically create a topic name based on the data coming out, and by default, if your security enables it, we'll create those topics for you on the fly if they don't exist under the specified tenant and namespace. Again, if you leave them out, we're going to put them in the public and default, which may not be what you want. This context is that SDK context that'll put errors right in an event stream. So if you want to process your logs, you don't have to pull them out of a text file somewhere and then load that into a stream. This is in a stream, so I can have a Flink or Spark or Pulsar app running and handle my own errors right in the stream. Doesn't need to be stored somewhere.
So here where do you get the namespace here? Like a namespace. Like this is
You would put, when we specify a topic, it is a full name of the topic is persistent : / tenant / namespace / topic, kind of like the way you do a JDBC URL. If you leave out persistent, we're going to default to that. If you leave out a tenant, we're going to default to the public one. You could also change the defaults in your client so that it'll put in one you have access to, because most organizations will lock down the public one. Maybe you just use that for testing or for demos or for learning, because you probably want that in one of your known tenants, because you may only have access to the, your line of business, and, your app may have its own namespace or own set of namespaces. So you might not want them to go to a generic one. That is up to you there. I could just send to Kafka. You're like, that's too weird, man. I don't want to learn a new one. Just use the Kafka library. That works. Use the MQTT library. Use the AMQP library. Use Flink's library, Spark's library. I'm giving you all these slides, but I want to get to the demo. I think I don't have much time here. I fooled around in the beginning because no one was here yet. This is a web page that calls Pulsar. Pulsar has a full WebSocket duplex interface. So I can consume messages from Pulsar via a JavaScript app that's just calling a WebSocket. And that can be fully secured with tokens. And that'll just pull the data back as a regular consumer of the object, gets its own subscription. So I could push in a Kafka message to Pulsar and have this WebSocket app read it out of there. Pretty straightforward to do that. It's not the hardest thing in the world. Down here, I've got a app using the new Spring interface. We're working on making a Spring native app, because in test that comes out in like fractions of a second to start up the app, which is nice. This is kind of silly little app, but this is reading from a REST interface and sending it to Pulsar. And the interesting thing I want to show you there, we're using the regular Spring app, using that Pulsar template, and I'm just sending the message here, giving it a key, and just have standard logging. What's unique here is there's a new feature in this Spring connector where I can intercept when that message is produced. So if I want to do logging then or auditing, I could do that. And it includes grabbing the schema of the event that was sent. And here I'm just logging it, but you could push it into a database or do something else. If you look here, that's that logging interceptor where I grab the whole schema and the data. So if you want to turn on debugging, it can be done through an interceptor. You don't have to have it in the code. And maybe that interceptor is something you have in all your code. You do it once, and now I've got everything. I'll see if I need to debug. I'll get my schema and the data, however you set that up, pretty straightforward. Also in the app here is a couple of consumers of data. Pretty easy to consume data from Pulsar. That's it. Set up a listener, give it a name, subscription type, schema, and what topic, and it'll just get the data. I'm just logging it, but you can use it for anything you want. So even easier to consume data. Or I could just use the consumer from Kafka or from MQTT or whatever you choose to enable. And for functions, this is how hard it is to do a function. You do that, you have a process here based on what you're going to return. And here I'm just parsing some data from a raw topic and converting it into a new schema based on some new data. Give it a key, set some properties of my own, and send it. It's very straightforward to do that. And if I'm in debugging mode, I'm going to debug it. Pretty straightforward Java stuff. but just to give you an idea what you can do there. We could do full Flink SQL against this topic data. So if you don't want to have to write an app, I could just have Flink do it, and Flink can join different data sources together. So I could join a Flink topic coming out of Pulsar with a Kafka one. Oh, it crashed. Network here is the best. But it's all that. We'll show you that in the later one. But the very simple to do that. Again, that's not really Java. And you could just, I've got links to all the source code and the videos. So yeah, I blame Flink there. They're in Scala. Free training if you want to learn this. We give you your own environment to try out, and it runs as long as you're running the training course. Completely free, and it shows you there's Java 1, Python, a couple different languages. We support most of the major languages if you don't want everyone on your team doing Java. And this is me. This links to all my details and all the demos, GitHubs, and all that sources. I will post these slides as soon as we're done and link them in the Twitter. And I'm sure when they send out the official videos, you'll see those slides again. If you have any questions, let me know. I have the world's cutest stickers if you're interested. I know the other talk's got to start soon.